Hello student, welcome to chemistry class. My name is Zoilami Titule, and today the topic we are going to be looking at is the part 3 of our acid, bases and salts. This is the part 3 and this is the last part. So let's be on the same page while you sit in a very conducive area with your writing material, and let's start the class. So over to the objectives of the third part of this class. We'll be looking at the solubility of salt in water by calculating the solubility and looking at solubility curves. Then we're going to talk more on titration, that's theoretical parts. What are the things you have to know about it before going into practical proper? So solubility of salts in water. Water is a very good solvent, as we all know, and it can dissolve wide range of solutes. Solutes are solid materials, while solvent is liquid material. Then when the ability of a solute to be soluble in a solvent is what we call as what? Solubility. Okay, so I'm going to use sugar and sodium chloride, which is our common salt, as an example this afternoon. Okay, looking at sodium chloride and sugar, you can as well dissolve various range of chemicals or salts in water, but I'm going to be particular about this. If sugar, for instance, if sugar can dissolve more than sodium chloride when you put both of them in water, for instance in 100 centimeter cube of water, okay, at the same temperature, the sugar is said to be more soluble than what? Sodium chloride. It dissolves completely. That's what it means. So the solubility of sugar is now said to be more than what? That of sodium chloride. Definition of solubility. Solubility of a solute in water at a given temperature is the number of grams of that solute which can be dissolved in 100 grams of water to produce a saturated solution at that temperature. Okay, so when you are talking of saturated solution, that means is the amount of solute that a solvent can dissolve at that particular temperature, provided the temperature is not increased. Of course, if you increase the temperature, the solubility can be increased too. Don't forget that. So calculating solubility, we're going to look at first example, which says calculate the solubility of copper 2 sulfate if 12.1 grams of copper 2 sulfate dissolved in 50 grams of water at the temperature of 30 degrees Celsius. Okay, our solution now. If 50 grams of water dissolve 12 points from our, from the what's it called, from the question given to us, if 50 grams of water, okay, that's 50 grams of water can dissolve 12.1 grams of copper 2 sulfate. You are now to calculate what? You have to calculate the solubility of that copper 2 sulfate. So this is how you're going to do it. If 50 grams can dissolve this, that means 1 gram will dissolve what? 12.1 grams divided by 50 grams. Okay, that's for 1 gram. And for 100 grams, for solubility of any substance, it must be dissolved in 100 grams. That's the standard. Okay, so if you multiply it times 100 grams, it will definitely give you what? 24.2. That's the solubility of that copper 2 sulfate in water. So solubility of copper 2 sulfate at this temperature of 30 degrees Celsius will be what? 24.2. Okay, solubility curve. That's the next one we are looking at right now. Solubility curve. It is well known fact that amount of solutes that a solvent will dissolve increases with temperature. Just like I said earlier on, we say solubility increase with increasing temperature. Okay, so the graph of solubility against temperature is known as solubility curves. When you plot the graph of solubility of a particular solute against temperature, this in temperature, okay, which can be degrees Celsius rather, and this one is in what? Gram per 100 grams of water. That's the, we are talking of solubility in gram per dm cube. Okay, so for instance, these are the keys. Okay, when you look at potassium nitrate, potassium sulfate, sodium chloride, and copper sulfate, these are the key you use in identifying them. For square, you have that one to be potassium nitrate, which is the first one. At 30, if you can do it this way, at 30 degrees Celsius, if you trace it up here, you see that the solubility of potassium nitrate at this 30 degree, okay, will give us what? Will give us something around, that's each line represents 2, that's 2 centimeters or 2 grams, whichever way you want to put it. So here you have something like 46, right? That means at 30 degrees Celsius on this very graph you have 46 for the solubility of that. You can always trace it to see at a particular temperature what the solubility of each of these products will give you, or each of these salts will give you. So let's look at, there are some representation we ought to know. You know, they are symbols actually. On some chemicals, you just see this symbol, you can see this, you can see this other one, you can see this, you can see this one, you can see this one, you can as well see this one. So how can you know? Because they won't write it in words. How can you know is a kind, what kind of substance that particular thing is? For instance, let's look at the first one. The first one, when you see this very symbol, that means that very substance provides what? Oxygen. That means it can oxidize. It's an oxidizing substance. It provides oxygen and allow other material to burn more fiercely. Okay, same thing with when you talk of this very symbol, something like fire, that means it's highly flammable. This one, when you see this edge, this curl and cross sign on the mouth, that means it's very toxic. Okay, it can wear off the body, or it can cause death. That's what it causes, death. That's what is the symbol really means. So when you talk of harmful material, you see them having H in between the cross sign. Same thing, corrosive, irritant, penetrating power, when you talk of all these radioactive elements. And this one, you have it very unstable. Okay, it can be explosive, just like your atomic bomb and what have you. So titration now. Titration, previously, you know, we say something, we saw a lot of things about how we can have a soluble salt. Okay, how to prepare soluble salts by reacting an acid with a soluble base. Soluble base is alkaline. Okay, so the method used was that of titration. I can still remember I told you that maybe previous class, either the second or the first class. Okay, titration can also be used to find the concentration of the alkaline used. For instance, when you have titration, either of the two, either the acid or the base, you call it titrant. Titrant means you know the concentration, as well as you can always get your volume when you fill up your burette or you. Okay, so we follow the steps where we have step 1, you prepare 25, then the steps 2 says you had you fill up your burette with what? To zero mark of 0.1 mole dm cube of the HCl acid. Okay, so these are the things you have to do. You have to use suction bulb, or you use your mouth, but in case of acid you use suction bulb. So the third step says the filter funnel is now removed, the HCl acid is added in small quantity, and you keep on shaking the conical flask until there is complete neutralization. And how will you know there is complete neutralization? There will be pink color will disappear while the colorless solution will appear. So here are the values. The volume of sodium hydroxide used is 25 cm3. The average value of my acid is what? 21.0 cm3. So we have to write the equation, balance it. In my equation is 1:1 ratio. That means the number of mole of HCl equals to number of mole of sodium hydroxide. So I can always calculate my mole of HCl, since I know the concentration of HCl, so which gives me 2.1 raised to power minus 3. And since from equation is ratio 1:1, that means the number of mole of HCl equals to number of moles of what? My sodium hydroxide. So here we are, we can always calculate what? Our molarity or concentration of sodium hydroxide. Since I know the moles, don't forget our equation that says concentration in mole per dm cube equals to what? Um equals to number of moles divided by volume of that solution. So you can always get it out. Then in this situation where we have it in cm cube, you change it to dm cube by multiplying by 1000. So that will give us 0.84 mole per dm cube of, or you can call it molarity. Okay, the same thing. So, and you can always use your C1 V1 equals to C2 V2, which is equals to number of moles, right? So anyone you feel like using is quite simple. So stay happy and make sure you lay your hands on some lot of questions that will help you out in this regard. Bye.